Hi, my name is Barbara Villarini, and I'm going to present the AI organ segmentation app that I developed during my Royal Academy of Engineering Leverhulme Trust Research Fellowship. The web app is developed in Streamlit and integrates deep learning models for the automatic organ segmentation from medical images. It enables 3D organ visualization and interaction. It has a user-friendly interface and is code independent. It can run locally or accessed through a cloud-hosted web browser. Overall, it can be used to extract morphological information for the 3D reconstructed organ and can enable clinical studies, collaborations, and integration across different disciplines. As a demonstration, I briefly walk you through the application with one of my datasets. So in the landing page of the web app, we can find some information about the research project. In particular, the aim and the objectives are described, and you can see an image that shows at high level the proposed segmentation framework. The idea is that from a radiological scan, we can obtain some prognostic biomarkers which can be used to predict a condition or its progression. The initial input is a 3D medical volume that goes through a segmentation process in order to get a 3D accurate reconstruction of the organ of interest. The segmentation result is then processed to compute the morphological features that can be used for the final prediction of a condition or for evaluating its progression. If we selecting the radio button, Publications and Code, you will find details of the articles that have been published regarding the project, and also the developed code is available on GitHub at these links. This project has been supported by the Royal Academy of Engineering Leverhulme Trust during a research fellowship, and selecting the option About, you can access some information regarding the founding scheme. Now, selecting a prototype option, we can access the web application and the segmentation functionalities. The user can either select a DICOM folder or a Nifty file related to a medical image volume. It is also possible to load a sample of MRI volume as demonstration. Let's select now a Nifty file from our computer. The file will be uploaded, and we will visualize three different views: the axial, the coronal, and the sagittal. It's also possible to change the slice that is currently visualized using the slider on top of the image. Now, for example, the image 113 in the axial view has been shown. And we can also visualize the metadata that are stored in the Nifty file. So if we check this box, we scroll down the page and we can see a table with all the values. Now, we can choose the organ to segment by selecting the related radio button. For example, let's segment the liver. So when the segmentation has been performed, you can see overimposed to the slice the segmentation outcome, and still you can change the slice to visualize the segmentation in a different slice. Once the segmentation has been performed, the user can also request the 3D visualization by checking this checkbox. So we can see now the 3D shape, we can enlarge, and we can interact with the shape by rotating it, by zoom in, zoom out. We can also download the plot as a PNG, and the same features applies in the main interface. Now, once the segmentation has been done, we can also calculate some morphological features by checking the last boxes. And the curvature and the volume of the organ will be calculated. So we just wait for the calculation to take place, and we can have in the table the volume and the curvature. We can also download this information in a CSV file, just clicking the link here. So I would like now to thank the collaborators and institutions that supported this project, in particular the host institution, University of Westminster, and the School of Computer Science and Engineering and School of Life Sciences. Thanks also to Harvard Medical Schools and Boston Children's Hospital for their continued support, UCL and University of Perugia, and also thanks to the Royal Academy of Engineering Leverhulme Trust for giving me the opportunity to work on this research project. And thank you for your attention.